So they tell me that dy dx is equal to x over the square root of 1 plus x squared plus sine x cosine x. And then they also tell me my initial condition is y of pi over 2 is equal to 0. Okay, so we need to integrate dy dx. I'm going to write it as two integrals. That'll be x over root 1 plus x squared. Of course, we'll integrate that with respect to x. And plus the integral of sine x cosine of cosine x. So the first one's probably going to be the easier one. It looks like it would be a u substitution.
This was a u sub, so let's just work it
So
out by
x
hand.
over root 1 plus x squared
X over
dx.
root
If we let
1
u
plus x squared
equal
dx. If we let u
1 plus x
equal,
squared, then du is
1
equal
plus
to 2x
x squared,
dx.
then
And then if we
du
take
is equal
half
to
of that,
2x
we'll end up with
dx.
x
And then if we take
dx.
half
So
of
that gets
that,
us
we'll end up with x
here.
dx.
So it becomes
that
integral
gets us
of
here. So it
1
becomes
over
integral
root
of
u du, which can be rewritten as the integral of u to the negative 1/2. So then that would be u to the positive 1/2. Oh, sorry, there should be a 1/2 out here as well. And then I think we need a 2 here, right?
Yeah.
We always have to multiply by the reciprocal of the exponent. So then, and this will actually also be a good opportunity to show you something else. We're never going to write, I don't know if you are aware of this, but we're never going to write anything like 1/2 c or 2c or whatever, because half of an arbitrary constant is still an arbitrary constant. So you're just going to leave it as c. You're never going to see this distribute across to the c term. So that way we're going to end up with u to the 1/2 plus c. So then when we plug back in, that'll be the square root of u, which could be rewritten as just the square root of 1 plus x squared. Or, equally stated, the square root of x squared plus 1 plus c. And that is the first part of that question. Now let's see what the other integral is. So we want to know the integral of sine x cosine of cosine x dx. Just assuming it's a u sub. If we let u be cosine x, that would mean that du is negative sine x dx. So that would take care of, that would make it the integral of cosine u.
Mm-hmm.
We'll have to work out where the negative comes from, but I think that's how it'll work. So we will have, like I said, the integral of sine x cosine of cosine x dx. We'll let u equal, what did I say, cosine of x, such that du is equal to negative sine x dx. Oh, that's where the negative comes from, right there. Right there. So then the negative du would be equal to sine x dx.
Okay.
And then it would become the integral of, what did I say, cosine u du, negative. And that would equal negative sine of u plus c, which when we plug back in would be negative sine of whoops, cosine x plus c. So altogether, we'll declare this as y. So square root of x squared plus 1 minus sine of cosine of x. And then remember that they tell us that our initial condition, sometimes notated as y naught, y sub 0,
Yeah.
of pi over 2 was equal to 0. So when we plug this in, we want to evaluate this at y equals pi over 2. So that shouldn't be too difficult. We'll have square root of pi over 2 squared plus 1 minus sine of cosine of pi over 2. And then we'll want to set that equal to 0. So then immediately what we'll want to do, anytime I see a positive term and a negative term, and we set it equal to 0, you can always very quickly and without hesitation bring the negative term to the other side and start your algebra. Right, if one minus the other equals 0, it means that the two quantities are equal. So
Okay.
let's see here. So that'll be square root of pi squared over 4 plus 1 equal, let's see, cosine of pi over 2. Off the top of your head, do you know that one?
Nope.
Let's see, I think it's 0, but let me double check. Let me use this calculator because the keystrokes are easier. Cosine of pi over 2, let me put it in radians before I do that. Quick, cosine of pi over 2 is 0, yes, okay. So sine of 0. So again, all of this stuff here, this is also equal to 0. So let's see here. That doesn't quite add up because all of this should be some quantity. Oh, that's right. Had a little moment there. Remember, all of this is, well, here, let me do this. Shrink this down just a bit. Remember, all of this is plus c.
Oh, yeah.
Right? So that's kind of our job, is to calculate c. We know this is our, what's it called? This is our general solution, and then our specific solution will be whatever includes that c term. And that'll actually be good vocabulary, if you didn't already know that, to kind of hang on to. So this here, again, this is a general solution. So if you see a question ever ask you for a general solution to a question like this, then you can leave it in this form. It means you're not given an initial value, or if you are, that it's not part of the problem. Okay, so all of this is equal to, let's see, let me just do like that, plus c. This part of the processing still holds. So let's just move. Oh, can I snag it without getting that radical? I think so. Oh. It doesn't take much anymore to make me happy. Clearly. All right, plus c. So then that means that if we, c should be equal to, well, actually, let's do, doing too much work already. So our specific solution is y equals, and then I'm just going to copy and paste all this. Minus this part here. So that's pi squared over 4 plus 1. And this is what's called, again, our specific solution, because it's specific and unique to that given initial condition where y of pi over 2 equals 0.